Hey guys, so here's part 2 of the 6.5 notes. We're going to talk about still graphing our square root and cube root functions, but now with some certain transformations. Okay, we're going to graph the following functions and state the domain and range. So we have y equals 1/2 times the square root of x. So in order to graph really any square root function, we're always going to use the same 4 points. And so those 4 points that we're going to use is like what we used with the parent function. It is going to be 0, 1, 4, and 9. Now, before we get into graphing, let's talk about what we see here. We have y equals 1/2 times the square root of x. So remember when we talked about the transformations are a, h, and k. Now we're going to get more into this when we actually have others. But remember with our a here, A can tell us if we reflect or we don't reflect. So if A is negative, there is a reflection. If A is positive, there's no reflection. Now, if the absolute value of our A is greater than 1, remember that's what we call a vertical stretch. If our A value is in between 0 and 1, and we want to take the absolute value of it, that's what we call a vertical shrink. So notice here that our A value is 1/2, so this is where we would say we have a vertical shrink. So that's what we talked about, like when we had absolute value, we talked about when we did quadratics, and now we're talking about again here. Okay, so now we know this means if we have vertical shrink, that means our graph is going to look a little bit wider in the sense, okay? Now, when we plug our x's into here, we do have to, once we take the square root of the number, multiply by 1/2. So I plug 0 into square root of x, and that gives us 0. 0 times 1/2 is just 0. Now, square root of 1 is 1, but multiply by 1/2, that gives us 1/2. Now, I take the square root of 4, that gives us 2. 2 times 1/2 gives us 1. And then square root of 9 is 3. 3 times 1/2 is 3/2. Okay, now I go ahead and graph this. So 0, 1, and then 1/2. I do 1, 2, 3, 4. That's 1. And then 9 is going to be 3/2. So you can tell definitely that's a little bit closer to the x-axis. Now let's talk about the domain and range. Now domain and range are going to deal with your starting point, okay? So basically, notice that our starting point is at 0, 0. Okay. So looking at the x's, right, I can see that I start at 0. We do have a bracket because it is included, and our graph is going to the right. So that means we are using positive numbers. Then for our y value, notice once again that we are starting at 0, and because our graph is facing up, that means we go to positive infinity. So you will always use your starting point to kind of help you out to figure out your domain and your range. Okay, now let's go ahead, let's do one with a cube root. Now this is going to be the same thing. Well, here we have y equals -3 times the cube root of x. So notice we are negative, so there is going to be a reflection. That means our graph is going to flip, okay? And because, make sure you take the absolute value of your A, since absolute value of -3 is +3, and that's greater than 1, we are going to have a vertical stretch. Okay, so just like we did with our parent function, we are going to use the same 5 points. And we will always use the same 5 points. So that's going to be -8, -1, 0, 1, 8. So that makes it a lot easier. Okay, so always use the same 5 points. Now, when we take the cube root of these values, we will have to multiply by the -3. So the cube root of -8 is -2 times -3 gives us a +6. Cube root of -1 is -1, and we multiply by -3 gives me 3. Cube root of 0 is 0. Anything you multiply with 0 is just 0. And cube root of 1 is 1 times -3 gives us a -3. And cube root of 8 is 2 times -3 gives me a -6. Now notice with our cube roots, the numbers repeat, it's just the signs are different. And that's what always should happen, okay? Your y values will always repeat, but you're gonna have different signs. So I go to -8, and then that's gonna be a +6. So 1, 2, 3, 4, 5, 6. Now notice because we have a vertical stretch, that means our graph is gonna get what we call narrower. So it's going to go faster here. Okay, then I go over to -1 up 1, 2, 3, 0, 0. Now I just reverse everything. So 8 down 1, 2, or 1, 2, 3, 4, 5, 6. There we go. So our graph's gonna go like this. There we go. Okay. Now the nice part, for all cube root functions, your domain and range will always be -infinity to +infinity, no matter what. So that's the nice part, because remember when we talked about inverses, when we have an inverse, your domain and range switch. Well, with cubic functions, remember the domain and range was -infinity to +infinity. And so that means that we just switch it, well, it's going to be the same. Okay, make sure you watch our last part of the video. That's where we're going to be talking with translations and more with our vertical stretch and shrinks, and talk about that with our square and cube root function.